This lesson is going to serve as an introduction to I, as it says, and what I want you to think about is the whole point and purpose of developing a different kind of number system. Typically, we talk about numbers in the real numbers as occurring on this real number line, where you have an origin of 0, and all of your operations, plus, minus, multiply, divide, occur on here. Plus has the effect of taking a lot of points, right, like any of those points, I don't really care what they are, and sliding them left and right. If I add, my numbers move to the right, and if I subtract, my numbers move back to the left. Multiply is an interesting operation. If I multiply by whole numbers, meaning numbers that are not necessarily negative, this has the effect of almost an expansion. So I don't know if I can quite do this as well as I want to, but the distance between points increases. Now that wasn't quite accurate, because if I multiply by 0, that stays. But if I multiply by 3, this moves out, and these also move out in the negative direction, but they also get further away from each other. So they expand, they kind of stretch that way and that way. So what I'm going to think about in this sense is that adding and subtracting is like a slide operation on the real numbers, and multiplying and dividing is like a stretch operation. Where if I multiply by numbers greater than 1, I expand. And if I multiply by numbers less than 1, meaning fractions, I shrink. So one of the big things here is to get the idea of what happens when I multiply by a negative 1. So if I multiply by a number by a negative 1, I'm going to actually start putting some numbers down here. So I'm going to have 0, 2, and negative 3. And if I multiply this 2 by a negative 1, what ends up happening is that it slides over and becomes a 2 here. It goes over to the opposite side. And if I multiply this negative 3 by a negative 1, it moves in that direction. And this little curious thing kind of leads to this idea of rotation, where, sorry, I should slide that over here, where if I actually consider this to be a two-dimensional grid, and I call this the real number line, and I put a 2 here, a 0 here, and a negative 3 here, and I want to make the operation be multiplied by negative 1, this is going to go like that, and this is going to go like that. And I'm trying to draw these circles to be just kind of a little bit meaningful, because now my new point here is negative 2, my new point is positive 3, right there. And that's the operation of multiplying by a negative 1. So we actually, this idea of rotation starts to get more meaning, where instead of being a negative 1, I can start to think about different operations. I can start to think about things like, what does it mean to multiply by, let's put a point here, let's call this 1. What does it mean to multiply by 2 in 2 steps? So I'm going to go and multiply by 2 and I get a point there, but if I do it in 2 steps, multiply by a number and then another number and then get to there, what I actually do is I get a number here and then I get a number there. It's kind of like a two-stepper. And it's not 1.5. What ends up happening is if I take 1 and I multiply it by the square root of 2 and then I multiply by the square root of 2 again, I get 2. And that's the effect of multiplying by 2 in 2 steps. You can reason through what it would be to multiply by 2 in 3 steps. I'm going to multiply 1 by cubed root of 2, by cubed root of 2, and then by cubed root of 2 again, and I get 2. So that would be a 3-stepper. The challenge here is to take a number, let's take this number 2, and I want to multiply it by negative 1 to get to negative 2, but I want to do that in 2 steps. So this idea of the rotation is now just going to be a little bit of a different type of thing. So I'm going to take 2 and I'm going to multiply it by some number, and then by some number again, and I'm going to get to negative 2. Well, clearly we've got a problem. I mean, you can see that if I put that number as x, and I have 2x squared is equal to negative 2, I get x squared is equal to negative 1, which is heretofore impossible. So what we're going to do is we're going to say, well, that number that makes this true is going to exist right here. It's going to exist halfway through that rotation. um, it's going to exist somewhere on this plane right there. And basically, that number that I'm looking for, I'm going to go from here to here and then to there. I'm going to do this in 2 different steps. So the 2 is going to be multiplied by something, which is going to get it here, and then it's going to be multiplied by that again, which is going to get it there. We're going to call that I, the imaginary unit. So basically what I would say is x is equal to I. And when I get x squared plus x equals I, what that means is that this little place right here is 2I. Now, what I'd like to think about this is the real number line, this is the imaginary number line. And this 2I just represents 2 units north on the I-axis. So some interesting properties come up with this. Think about what's happening with this operation. If I take 2 times the number I get 2I. And then this operation is 2I times another I, which gets me -2. A few things happen with that. I squared is equal to -1. That's a huge one. We have I squared equaling -1. That means that suddenly problems like this have a solution. Now, sliding back over here, I could have just as easily said that x could be -I. Now, how do I know that? Well, this idea of that we've been talking about the last few days, if I take a square root of both sides, I'm going to kind of move that down here. I have the absolute value of x is equal to the square root of -1. So a second consequence of this is that we're going to say that I acts like the square root of -1. And I'm going to call acts like because we really don't like to ever leave things in terms of the square root of -1. But I still have that absolute value, and that absolute value still creates a case where I have x is equal to the plus or minus square root of -1, which we call plus or minus I. So what's negative I? Well, if I take 2 and I multiply it by -I, I actually go in the negative direction. So this is 2 times -I, which gets me right here at -2I. And then I'm just going to go back this way. When I multiply -2I times -I, I get this. I get the same thing. Now, whichever direction I approach, this point acts or looks like it to be 2I squared. But 2I squared is going to be equal to -2 because I squared is equal to -1. I bring this up just as an intro. I don't want you to necessarily write this down, but I want you thinking about what it means to be I as we do this next day. I brings about a new dimension in numbers, and this plane here is going to be called the complex numbers. It's a new number system. It's greater than the real numbers. It's more inclusive. So we've always had this like real number line that was composed of rationals and irrationals, but now we're going to make those a subset of a larger set of numbers called the complex numbers with the funky C thing. As we hit the next day, we're going to not only talk about numbers that occur on the real number line and numbers that occur on the imaginary number line, but we're going to actually talk about the entire plane, numbers that can occur anywhere in here. So it's a stretch. It's a different way of thinking. I get that. I don't want you to get overly burdened because the math we're going to do is not going to require you to know too much about the complex plane. But every number in here has a representation. This number right here, for instance, it is 3 on the real numbers, but it is 1I or I on the imaginary numbers. So it is 3 plus I. That's how we describe it. Whereas this number here would be well, let me kind of do one here. This would be a -2 on the real numbers and a -2I on the complex numbers, so we call it -2 minus 2I. And every number is going to have a representation in there. There's one number that's both real and imaginary, and that's 0. We can express 0 as 0 plus 0I if we wanted to, whereas like 3 would be 3 plus 0I. And I right here I could rewrite as 0 plus I, and -2I down here I could write as 0 minus 2I. And -2 to the left here I could do as -2 plus 0I. And now every number has a real and an imaginary part. So part 2 of this is going to show what you're actually going to be doing. And I insist, don't worry about writing notes down for this part, just kind of watch it and be thinking.